Okay, guys, so today we're going to do Introduction to Basic Statistics. Okay, some of this you've already done. So Ms. Delka's already filled in the vocabulary. We all know that teachers are mean. Remember, I say this, Ms. Delka say this, because we take the average of your grades. So the mean is the average of the values. You can see her definition there, mean equals the sum divided by the number of values. We all know how to get the median by this point. You add them up from least, or add them up. You don't add them up. You put them in order from least to greatest and take the middle value. Remember, if there happens to be two middle values, you would take those two numbers and add them and divide by 2.
Take the average of them.
Yes. All right, mode is the most occurring value. Remember, we used to say mode is the one that you see the most. They kind of sound like each other. And then we went ahead and filled in range, because that's another term you already know. That's always the largest number minus the smallest number.
These are all the things we've done on the minutes so far.
Yes, so we just kind of filled that in to keep the video a little shorter. Okay, so we're gonna go an introduction basically to box and whisker plots, like how to build them, what they mean, things like that. So we're gonna do lower extreme. And I just want you to think about like the terminology of that sounds like, if you think about the lowest extreme, sounds like the lowest or smallest value. Okay, y'all have heard us say in math, we call things what they are. Lower extreme, the smallest number.
We're not good at naming things in math.
Upper extreme, on the exact other end, would be the largest value. Okay, easy enough. All right, here's where some things come in that y'all kind of don't know about. So lower quartile, that is the median of the lower half. So you're gonna put your numbers in order from least to greatest. You're gonna go find your real median, like the median of the whole set of data. Then you're gonna go to the lower half of the data and find the median. So that would be your lower quartile. Okay, Ms. Delk is writing, sometimes you're gonna see that as Q1.
Because on a box and whisker plot, it's the first quartile. It's the first part of our box.
And we'll show you what that means here in a minute. Okay, upper quartile, kind of the exact opposite. So it's the median of the upper half. Guys, you're gonna put your data in order from least to greatest. Truly, you would find your true median first, the middle number.
You're gonna find this one that splits the data into two sets. The upper quartile is the median of the numbers to the right of this value.
Right.
And we call it Q3.
Yes.
Because they're in order. Q1, this is technically Q2, because it's the true middle. And then this is the last middle number that we'll find.
Good. So interquartile range, when we build these box and whisker plots, you're gonna see there's 4 quartiles. The inner quartiles are 2 and 3, like the insides of the box. So you're gonna take the median of the upper half and subtract the median of the lower half, and that will give you your interquartile range. Basically, that's gonna give you the size of this box, the range of these boxes right here. And it's gonna be your Q3 minus Q1.
Okay.
Okay, so first thing we're gonna do, we're gonna look at the data, the numbers they gave us.
And I always put them in order from least to greatest before I do anything. It's just a habit.
Yeah, that's a habit both of us will do. Like, we don't do anything till they're in order. And kind of look, watch Ms. Delk, she's kind of writing them above it to make sure she uses all of them. I always kind of count real quick, make sure I've got the same number, so I don't run all this data and then have one number missing and everything's wrong.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 originals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, all right, we're good. So see how she put it in least to greatest order. Okay, so let's go fill out what we need. The mean. So the mean from the top is the average of all the values.
So I'm going to add them all up, and I would get 130.
We've kind of done some of the math already so that we don't waste time.
Don't feel bad. I didn't do that in my head. Divided by how many there were? There were 10 numbers. So the mean or the average would be 13.
Okay. All right, median. Median is the middle value of your data set.
So I'm going to work my way from the outside to the inside. So 1, 1, 2, 2, 3, 3, 4, 4.
Oh, good. Perfect example.
2 in the middle. So right here is the median. To find the median, I take the average of 10 and 14, which would be 12.
And look at, like, truly, 12 is the middle number between 10 and 14. Logically, that would be your median. Okay.
Okay, let's go do the easy ones.
Yes.
I would do mode, the one that occurs the most. The number that occurs the most is 10, because there's more 10s than any other number in the data set. Probably the next easiest will probably be range. It's the biggest number minus the smallest, and 25 minus 4 is, in fact, 21. That's all the stuff y'all have done before.
All right, now let's go do, we've already got the definitions up here, so that means we can go apply what we need to know down here. So if we needed lower extreme,
That's the smallest number, so that should be the one to the far left, which is a 4.
okay, easy enough. Upper extreme, remember that what the
Far right.
definition was the largest value. All right, easy enough, can't mess that up. All right, now let's go deal with some quartiles. Okay, the median, the lower quartile, we're gonna focus on that. It's the median of the lower half. Ms. Delk's already split your data in
So
half.
here's the median. I'm going to find the median of everything to the left of it, not including it to the left. So I'm going to get a different color so I can show y'all that better. So I'm going to do the same thing I did with the original, but just to the left. So I'm going to work my way from the outside to the inside. So I've got 1, 1, 2, 2. Here is my median of the lower half. So that's my lower quartile, and it's 10.
See how easy she did that?
I'm going to do it again to the right, because now I'm going to find the median of the upper half, the upper quartile. 1, 1, 2, 2. Here's the median of the upper half.
Okay. All right, how we get that interquartile range?
It's Q3.
So upper quartile minus lower quartile. So Q3 minus Q1, or Q, yes.
Q3 minus Q1, and we get 6.
Brian's not, hadn't had that coffee yesterday. All right, look at there, look how easy. Okay, everything you have to build a box and whisker is right here.
It's really simple. All you have to build a box and whisker plot is you have to find me in the middle 3 times, and then I need the biggest number and the smallest number.
Yes. Think in 7th grade when y'all did these, they made it real difficult. It's not that difficult. You already have your 3 middles. You've got the middle of all your data, which is 12.
12. Then I've
I was
got
just pulling it from right here. Here's a 12, middle of the data.
middle of the lower half was 10, so that's
She's gonna
about
put a
right
line
there.
at 10
Middle of the upper
was
16, so about right there. That makes
the box.
the box. The 3 middles make the box. And now you can see why we call these Q1, Q2, Q3, because they're in order. Q1, Q2, Q3. Okay, then the whiskers are the upper and lower extremes. So the smallest number was 4. So I'm going to put a little dot right here at 4
And run a whisker.
and run a whisker. Then the upper extreme was 25. So I'm going to go put a dot about here at 25. And I'm going to run my whisker.
So look at that. We had 3 middles, 3 medians, and we ran to lowest number, highest number, and that's a box and whisker.
Yep.
Okay, here's what's important to know. Here's what Ms. Delk and I focus on every year. This thing is built in quartiles. So notice there's 4 pieces to this thing. First piece, second piece, third piece, fourth piece. And this piece, all the way to here, represented Q1. Like this is your first quarter of the data, second quarter of the data, third quarter of the data, fourth quarter of the data.
You can even see that here. First quarter, second quarter, third quarter, and fourth quarter.
Okay, so if you think about each box and whisker, this box, and this whisker, each of them are a quarter of the data. So they're worth 25% of the data.
Regardless
it.
of size.
Yes, don't worry about the size. 25% of our numbers are covered in each of those box and whiskers, each of the pieces. That is, if you get anything, that's what we want you to understand.
And you can see that here, right? Because there were 10 numbers, and a quarter would be 2.5. So we've got right here, we've got 2.5, 2.5, 2.5, 2.5.
That's right.
In each set, because this splits it. This splits it. So 2.5 over here, 2.5 are in here, 2.5, 2.5.
So if you can find 3 medians, median of the whole data set, median of the lower half, median of the upper half, you have your box, run your whiskers.
Okay, I'm going to show you how to do this real quick. This time they gave us a box and whisker plot. They actually gave us two, and we're going to be comparing them. Notice I don't know what the data is. I don't know the original numbers, okay? So it says, what is the median of each set? Well, the median is Q2, meaning it's the second part of the box.
Right here.
Q2. It should be the second part of the box. So right here, I've got 70 for A and 70 for B. This is Q2.
Notice how they have the same median. Okay.
Okay. Which plot has a lesser range? Remember, range definition, it's the biggest number minus the smallest. Well, that should be your upper quartile minus your lower quartile. So for here, I would have 100 minus 45. Is that right?
This one?
This
It's,
one?
50.
No, I'm crooked. Sorry. So this one would be 50. And then this one would be 100 minus 40, which is 60. So the one with the least amount of range would be A.
A. Okay.
Okay, inner quartile range, that's Q3 minus Q1. So right here is Q3.
Remember, that's the third quarter of your data.
And then right here is Q1. So the inner quartile range would be this one minus that one. So that would be 80
minus 65.
15. And then right here I would have
I
85.
got 85 minus 60.
And I got 25. So the one with the greater inner quartile range would be B. Okay, upper quartile of each set. So upper quartile, that's Q3. Remember definitions, Q3. So Q3 for A,
Would be
we said was 80.
80. Mm-hmm.
And then for B, we said was 85.
And she's pulling those from right here. Q3, Q3.
Definition of a lower extreme is the smallest number. It should be the whisker. So right here are my lower extremes. So for A,
We have
50,
A would be 50.
and B would be 40.
40.
Okay, and then here's where that percent stuff comes into play. It says what percent of the data in plot B is between 60 and 85. So
B.
60 to 85. Remember, each section is worth 25% of the data. So if this is 25%, this is 25%, this is 25%, this is 25%, then from here to here, that would be 50% of the data.
See how we're doing that? Like every piece is worth 25%. So add up what they're needing.
Okay, 25%, 25%, 25%, 25%, each section.
No matter the size.
Yep. Greater than 80. So here's 80, here's greater. That is 25% of the data.
Okay. Last one says, what percent of the data in plot B is less than 85?
So here is 85, less than, that would be this direction. So that's these three sections. So that should be 75% of the data.
Okay. See how easy? Pretty easy. Okay. All right. Flip over. Trying to think what we're. Okay.
Okay.
So these kind of apply it. So it says biologists are studying the weight of an albacore tuna caught off the coast of Washington State. A sample of the tuna is taken and their weights in pounds are given below. So first of all, I kind of count how many tuna. So they call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19. They call it 20 tuna.
I'm going to go ahead and I'm going to put them in order. So I've got
That's what we're going
12,
to do first every time.
18, 19, 20, 22, 22 again,
25.
25, 27, 29, 31, 32, this is not fun, 34, 35, what's next, 36, another 36,
Right, a little smaller, Ms. Delk.
38. I'm running out of room. 41, 41. I don't write small. 41,
48.
48.
And 50.
And 50. Ha, I got it on.
Okay, we got it on there.
Barely. Sorry.
Okay, we put them in order. First thing. Okay. This question asks for which is the greater measure of center. Your two measure of centers is mean because it's the average, median because it's the middle.
And you can do that.
Yes.
Y'all can find the mean, y'all can find the median,
We're gonna
and
let
then
you
which
do
one's
that.
bigger.
We'll check it.
I'm going to practice doing a box and whisker plot. Remember, to do a box and whisker plot, you have to find me a middle number 3 times. Biggest number, smallest number are the whiskers. So I'm going to go and I'm going to find the middle. So I'm going to work my way from the outside to the inside. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. There's 2 in the middle, so I have to take the average of them to split my data. And the average is 31.5.
And that's a true. Like, look at 31 and 32. If we ask you to half them, it would be 31 and a half.
And that's about right here. That's the first part of the box. That's the first middle. Now I'm going to go find another middle number. I'm going to do the lower quartile. So
Okay.
Q1, I'm going to do the lower half. Same thing.
So middle of the lower half.
So
Watch her.
1, 1, 2, 2, 3, 3, 4, 4. There were 2 again. Take the average of them, and I get 22. So Q1 is 22. That's about right here.
If you added 22 and 22, you get 44. Divide it in half, you still get 22.
Okay, upper quartile, median of the upper half. So to the right of the original median. So 1, 1, 2, 2, 3, 3, 4. There's 2 in the middle again. I split it, and that's 37. So Q3 would be 37. That's about right there.
And notice how our boxes are not the same size, but both of them are going to count for 25%. And she's showing that. Here's 25% of her data, 25% of her data, 25% of her data, 25% of her data.
Now my favorite part, I like the whiskers because they're the easiest. Whiskers are the smallest number or the lower extreme, which would be 12. So right here, draw my whisker. And then I've got the upper extreme, which
50
would be 50. And connect.
So think about that. It means the lowest pound fish they caught was 12 pounds. The greatest size fish they caught was 50 pounds. And the median size fish they caught, the middle of the sizes, would be 31 and a half.
Yep. And y'all could do range. Remember, range is the largest number minus the smallest. I'll let you do that. But I do want to do this one. It says, what percent of the data lies at or below a weight of 37 pounds? Well, remember, 37 was Q3. And each section represents 25% of the data, always, regardless of size.
So at or below.
At or below,
37.
that would be all of this. So in total, that's 75% of the data.
And a lot of these questions are going to be based on those percentages because that's the true focus of the box and whisker.
In addition, a lot of times what they'll do is they'll give you a box and whisker plot, and in the information, they'll say they caught 20 tuna, and they'll say what percent of the tuna are 37 pounds or below, like they did here. And then they'll say, well, how many tuna would that be?
Ooh, that's a
well,
good one. Yeah.
if there's 20 tuna and it's 75% of the data, then I would need to do 20 times 3/4, which should be 15 tuna.
15 tuna. So you got to think about it. They're going to give you probably the number of things, or we know how many they caught.
We
so
know
they
it because they
ask.
gave us the data, but a lot of times on the EOC, they'll give you a box and whisker plot.
Right.
And in the information, it'll say the box and whisker plot represents the data for 20 tuna.
Yeah.
What percent were 37 below? How many tuna would that be? So you would have to take 75% of the total tuna caught.
Yeah.
And we could prove that because right here, that should be 15 numbers below, which it is.
Yeah. Okay.
Okay.
All right. We're going to build one more just so you see it. It says, oh my goodness, Dr. Wittgenstein is researching the time it takes for people to fall asleep at night. In his lab, he records the time it takes each of his subjects to fall asleep in minutes and compiles the data set shown. Cannot talk. Have not had my coffee. Sorry. Data set shown below. So I'm gonna quickly count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We know he collected data from 16 people. So that could definitely be significant in your questioning on EOC.
And notice I went ahead and I put them in order from least to greatest before I do anything.
Easiest thing.
Y'all can find median.
Yeah.
I'm gonna let y'all do that. It says, are there any outliers in this data? Well, an outlier is a number that's really far outside of the data range. Look, we went from 7 up to 32, and then all of a sudden it took this person 95 minutes to fall asleep. I would consider them an outlier.
definitely an outlier.
Yes, that is an outlier. They want to know what would be the mean and median if you took away that outlier. I'm going to let you do that.
Yeah.
And then you can compare these two answers and determine which one was affected the most. Okay? I'm going to go ahead, though, and construct the box and whisker plot using the original set of data. Okay? So, to construct a box and whisker plot, we have to find the middle. We have to find Q2.
Find your middle.
So 1,
Middle of the whole thing.
2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. Once again, there were 2 numbers in the middle, so I'm going to split it. And that would be 18 and a half for Q2. So 18 and a half is about right there.
Okay, we're not, I mean, as long as it's about in this right spot. Ms.
We're
Duck
not-
and I will
I'm not that
grade you
picky.
on- Right. Okay, now she's gonna go find the middle of the lower half.
So the lower quartile.
So remember, this is Q1.
And once again, I had 2 numbers. I'm splitting them. Half of 14 and 14 is still 14. So that's
A
about
little
right.
bit of box right here. So watch how little these are gonna be. That's a good one, because they're all gonna be different sizes, but still 25% of your data.
Now I'm going to find the upper quartile, the median of the upper half. So 1, 2, 3. Halfway between 22 and 25 would be 23 and a half. Yep.
Okay, she's gonna go put her the other box down here. So look at those 3 middles. Look at the size of those little boxes.
They still represent 25% of the data. Okay, now the easy part, the whiskers. Smallest number was 7, so that's about right there. Draw my,
Look at that tiny whisker.
that's so cute. And then the upper, way over here, 95, with that
at that
outlier.
size of that
See why we
whisker.
called it an outlier? Let's look how far it stretches our data.
So look at that box and whisker. It's the first one you've seen kind of where they all don't similarly are the same size. They're very different sizes.
Still 25%.
Yes. Most important thing.
25%, 25%, 25%. So on the EOC, they could ask you what percent of the data took more than 23 and a half minutes to fall asleep. Here's 23 and a half. More than that would be 25%. Then on the EOC, they could say, well, they did 16 people. So what percent of the data is that? 25% of 16 is 4. It took 4 people. It doesn't look like it, but it took 4 people 23 and a half or more minutes to fall asleep.
Okay. Easy enough. We got a homework sheet. We're going to check these numbers real quick and then give you a homework sheet so that you can focus on these box and whiskers tonight.
And tomorrow.
Yes.
Bye.